Hello, everyone. Good morning, afternoon, or evening. Dear authors and invited guests, welcome to Technical Session 4B. My name is Alesha Mullah, and I will be your moderator for this session. On behalf of Global Knowledge Research Foundation and GR Scholastic, it's my great pleasure to welcome you to the 11th International Conference on Information and Communication Technology for Sustainable Development, ICT4SD 2026 in Goa, India. The 11th edition of the conference is being organized in a hybrid mode. The physical event was held today in Goa, and the virtual event is being held from 9th to 11th July 2026 via Zoom. I hope you will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we will have 10 presentations. Each presenter will be given 10 minutes for the presentations and 2 minutes for question and answer. On the 9-minute mark, I will raise a gentle reminder. There is another request to all the participants. Please stay with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we start the session, I would like to introduce you all to the chair for today's session. Dr. Rupali Vairagade is an associate professor in the Department of Cybersecurity at Shah and Anchor Kachi Engineering College, Mumbai. With over 16 years of academic experience, she specializes in IoT security, cybersecurity, blockchain technology, and operating systems, demonstrating expertise in advancing critical areas of computer science and digital security. I would like to request you to please say a few words.
Yes, ma'am. Thank you and good morning to everyone that will be present in the meeting. Thank you for the good introduction. So as I have specialized in the few, so I will try to give some feedback, whatever maybe the paper will be presented in the conference. So it is my pleasure to be with all the participants and wish you all the best. Thank you, ma'am. Am I audible?
Yes, thank you so much.
Thank you.
Now I would like to request the first paper to begin. We have Prakriti Patel, who will be presenting a comparative study of filter-based and embedded feature selection methods for static malware detection using machine learning. Prakriti, you may now begin.
Okay, thank you. Good morning, everyone. Am I audible?
Yes, you are.
Is my screen visible?
Yes, it is.
Okay. So good morning, everyone. I am Prakriti Patel from Department of Computer Engineering, Charosite, India. Today, I will present a work titled A Comparative Study of Filter-Based and Embedded Feature Selection Methods for Static Malware Detection Using Machine Learning. This work has been carried out under the guidance of Dr. Nikita Bhatt along with my co-authors. The objective of this research is to investigate how different feature selection techniques affect the performance of machine learning models for static malware detection. So before discussing about the methodology, we'll first see what is the malware. Malware refers to any software that is intentionally developed to damage computer systems, steal sensitive information, disrupt services, or gain unauthorized access to devices. Examples includes virus, worms, trojans, ransomwares, and spywares, etc. As digital infrastructure continues to expand, malware attacks have become increasingly sophisticated, causing enormous financial losses and security risks. Therefore, accurate and efficient malware detection has become one of the most important challenges in cybersecurity. This slide illustrates the rapid growth of malware over the recent years. Every year, billions of new malware samples are discovered. In addition, Windows continue to remain the most targeted operating systems due to its widespread range. The figure shown here highlights why conventional security solutions struggles to keep pace the continuously evolving malware strategies. The increasing number of malware variants makes automated detection techniques essential. Traditionally, there are two types of malware detection techniques. The first is signature based. It compares the files against the database of known malware signatures. It performs extremely well for previously identified malware but completely fails when encountering new or modified malwares. The second approach is heuristic based detection. This uses predefined rules to identify suspicious behavior. Although it can detect some unknown threats, attackers frequently evade these rules using code obfuscation and picking techniques. Therefore, both techniques have limitations in today's rapidly changing threat environments. The limitations of the traditional malware approaches, the major challenges of traditional malware techniques includes the inability to detect the zero-day malware, dependence on manually updated signatures, predefined heuristic rules that attackers can bypass, and the massive increase in the malware volumes. Furthermore, modern malware often employs sophisticated evasion techniques, making manual analysis increasingly difficult. These limitations motivates the use of machine learning for the malware detection. Need for machine learning for the malware detection. Machine learning provides a data-driven approach. Instead of relying on manually created signatures, machine learning models learns the patterns directly from historical malware samples. This enables the detection of previously unseen malware. In our work, we focus on static malware analysis, meaning that the malware is analyzed without executing it. Several types of static features includes the opcodes, API calls, opcode sequences, strings, engrams, file entropy, and many more. These features collectively captures the characteristics of executable files and help the machine learning distinguish between the benign and malicious software. So this is my experimental setup. Now, our experiments were conducted using the NVIDIA DGX Station A100 computing environment. The implementation was carried out using Python 3.10 together with widely used machine learning libraries include scikit-learn, NumPy, Pandas, and Matplotlib for pre-processing, model development, and visualization. Using this experimental setup ensured efficient training and fair comparison across different feature selection methods and classifiers. Dataset description. Our experiments were conducted using the BODMAS dataset, which is a benchmark dataset designed for the static malware analysis of Windows portable executable files. I would like to mention an important point regarding that dataset that during the course of our research, the dataset was not publicly available. Therefore, we have requested the author to access directly, and they have kindly shared the dataset with us for the research purposes. The dataset consists of 1,34,435 executable samples, where each sample is represented by 2,382 static features. Since the target variable is categorized with the only two possible classes, this problem belongs to the supervised machine learning and specifically a binary classification problem. This proposed framework, this slide summarizes the overall methodology followed in our research work. The first data set shape. Then we have next comes the important stage of our work, feature selection methods. We have implemented two types of feature selection methods, embedded and filter based. After selecting the most relevant features, we have splitted the testing and training into 70-30 ratio. Then the machine learning models were trained and using the reduced feature set. Finally, the trained models are evaluated using classification accuracy to determine which feature selection approaches were wasting overall performance. Now let us move to our experimental results. The first set of experiment evaluates the filter-based feature selection methods. In this study, we have implemented three feature filter selection methods: chi-square, information gain, and feature score. The chi-square measures the statistical dependencies between each feature and the target class, whereas information gains measure how much uncertainty about the class label is reduced. Feature score evaluates how well the feature separates the two classes. Looking at the graph on this slide, we can observe that chi-square consistently achieves the highest classification accuracy across the different feature size. Overall, among the evaluated feature methods, chi-square proved to be the most efficient feature selection techniques for a malware detection framework. The next experiments focuses on embedded feature selection methods. Unlike filter methods, embedded perform feature selection during the model training process of itself. We have experimented 4 embedded feature selection methods: tree-based, L1 regularization, gradient boosting, and elastic. And now we can observe from the graph carefully that among all the embedded methods, gradient boosting consistently gives the highest accuracy across the most of the models. Compared to filter model, embedded methods provide better optimization since feature importance is calculated based on the actual model performance rather than statistically dependence only. Now, The slide directly compares the best performing filter methods and best performing embedded methods. Specifically, we have compared chi-square against the gradient boosting. However, the result clearly shows that gradient boosting achieves slightly higher accuracy across most classifiers and feature sizes. However, then maximizing detection technique is a primary objective. Embedded methods, particularly gradient boosting, provides the highest overall performance. Result discussion. Let me summarize the key findings from our experiments. The first important finding is that feature selection significantly improves malware detection performance while reducing the computational complexity. Second, among the filter base, chi-square consistently performed the better, demonstrating the statistical dependency is highly effective for selecting malware-related features. Third, among the embedded techniques, gradient boosting provides the highest overall performance, indicating that feature importance learned during the model training captures complex relationships more effectively. Across nearly all experiments, random forests consistently achieved the highest classification accuracy. This is expected because random forest combines predictions from multiple decision trees, reducing overfitting while maintaining strong generalization capability. The combination of effective feature selection and robust classifications lead to more accurate, efficient, and scalable malware detection system. Finally, let me conclude my presentation. The objective of this research was to compare filter-based and embedded-based feature selection methods for static malware detection using machine learning. The experimental result clearly demonstrates that the feature selection plays a crucial role in improving malware classification accuracy. Among the filter-based, chi-square emerged as a strong performer. Among the embedded methods, gradient boosting achieves the best overall result. Furthermore, random forest consistently delivered in a highest classification accuracy among the evaluated machine learning classifiers, making it reliable choice for machine learning detection. Overall, a proposed framework successfully reduces feature dimensionality while maintaining excellent prediction performance. Like every researcher studies, this method has also some limitations. Our experimentally focus only on static analysis. While static analysis is fast and safe, it cannot observe the runtime behavior. In future work, we plan to investigate dynamic malware analysis, where executable files are monitored during execution to capture the behavior characteristics. Before I conclude, I would like to acknowledge my supervisor and Charusat for their continuous support throughout this research. Thank you. Any questions?
Yes, ma'am.
Yes, ma'am.
Hello, Ashlesha, ma'am.
Yes, ma'am. You may ask your questions now.
Yeah. Good presentation. I have gone through your all the slides. Can you please move to the slide number 12?
Embedded feature selection methods.
Yes. The one important thing I want to ask you, I think you are the PhD scholar, and you are basically focusing on the static malware detection.
Yes, ma'am.
If I want to, the data set that you have considered, it will be the okay. But rather than the static, if I want to analyze, because whenever you are detecting the malware, in that case, it would be possible you can go for the dynamic malware detection too. So have you
Yes.
tried something which will be related to dynamic malware detection?
I have read many papers, and I have somewhat got the malware executable so that we can execute to the Cuckoo sandbox for the dynamic analysis. I have started in the starting phase only.
So have you done any comparison between the static malware and the dynamic malware detection?
Not experimentally, because the data set for the dynamic analysis is also not publicly available. So, our first step is to obtain the data set for dynamic analysis.
So based on the result, I think you have that is worked already on your first or second objective, which will be related to your work. And within that, you have get the accuracy that you are showing with the help of the different algorithms, right? So the
Yes,
accuracy that you have achieved, I think according to the future perspective, you can go for the dynamic malware detection. It will be better if you want. You can that is check and create your own data set too, probably. So it is going to give you the good parameters because in that you are the classification that you are maintaining. Have you tried with the cat boost and the light GVM method for the same?
Actually, ma'am, she has already started working on the collection of dynamic data sets. So for the same bottomless data set, we have collected the binary executables, and in the isolated environment, we are trying to create the dynamic data set where dynamic features are there. And we also do the comparison between the malware detection for static and dynamic feature selection. So the first task she has already completed. After static analysis, she has created the dynamic data set which is used to predict the polymorphic malware. We have done the comparison, but it is not scope of the work for this paper. In the next subsequent like our work, we are going to focus on the dynamic data set generation and the prediction of polymorphic malware.
Yeah, ma'am, definitely sure. One suggestion which is in your work, I would suggest if you, whatever may be the classifiers that you have used in case of the machine learning. So all these are the generalized classifier. So I would suggest if you can go for XG boost, if you might heard about, or the ADA boost, it will be the new technique which will going to be identify the multiple weak classifier and it will going to be focused on the misclassified sample. So the techniques that you have used, rather than you can go for the ADA boost, and the one I would suggest the cat boost, it will also going to be help you in your categorization. So these two techniques, it will going to help you a lot to achieve again the good accuracy. So it's just a suggestion. If you want to incorporate, you can incorporate.
Okay, thank you, ma'am.
Thank you so much.
Thank you.
All right, thank you so much for the presentation. We'll move on to the next presentation now. And next, we have Kanchan Vaishnav, who will be presenting a scalable, trust-aware, and infrastructure-free blockchain-based framework for vehicular ad hoc networks with on-vehicle access point station mesh communication. Kanchan, you may now begin.
Am I audible, ma'am?
Yes, you are.
Okay. So, good morning. I am presenting our work on a trust-aware blockchain based VANET framework that removes the need for roadside infrastructure entirely. The key idea: every vehicle owns Wi-Fi radio becomes both an access point and a station, forming a self-organizing mesh. We will show this achieves the 91.4% attack detection accuracy, and it delivers the safety alerts in 68 milliseconds across the 10 hops. So with zero roadside units. So two problems actually. Two problems motivate this work. First, the cost. So deploying the single side unit runs the approximately $50,000 to $150,000 and making nationwide coverage infeasible in rural or developing regions. So second is the WHO data shows that 21% of the road fatality in South Asia and 18% globally happens in low visibility conditions like fog and night driving. So where onboard radar camera and uh, cameras are blind beyond the uh, line of sight. So we need a cooperative infrastructure free solution for both these problems. So our extended framework makes the four contributions. The infrastructure free vehicle to vehicle mesh architecture itself simultaneously work as a access point and station mode for every vehicle, and a cascade trust relay that propagates the blockchain trust evidence hope by hope. So the dashboard safety overlay system that visualize the nearby vehicles, and in real time a low visibility protocol stack that guarantees the latency bound for safety critical alerts. So looking forward to our work, no existing approach combines all these properties. Some are roadside unit free but lack of trust integration. Other have blockchain trust but no multi-hop relay dashboard overlay. So infrastructure free vehicle to vehicle mesh architecture is the first to deliver all six properties together: roadside unit free, multi-hop, trust integrated, dashboard enabled, low visibility, safe, and blockchain backend. So here Here, the core mechanism of this work, each vehicle splits its physical Wi-Fi radio into virtual interfaces, virtual interfaces, and access point broadcasting to the vehicle behind it and the station connecting to the vehicle ahead. This forms a bidirectional chain V1 through Vn. So SSID rotates every 300 seconds for privacy, and the time division scheduler keeps connection setup under 50 milliseconds, fast enough for highway speeds. So to keep up with fast changing topology at highway speed, we use the active beacon response protocol, 100 milliseconds beacons, a neighbor table that expires every 500 milliseconds, an association rule that balance the signal strength and the trust score and handler in the under 50 milliseconds when the link is degrades. So safety message propagates hop by hop with cryptographic chaining. Uh, each relaying vehicle signs the message it forwards. This creates an auditable path and lets receivers rejects the evidence from any chain containing a low trust node. We bound this at 10 hops, which covers about 1,500 meters and approximately matching the 10 hops, the recommended hazard perception distance at highway speed. So we normally derives the density needed for the mesh to mesh stay connected with 150 meters. So access point range, the critical threshold workout about the 13 vehicles per kilometer, a density routinely exceed a highway and the overlay roads, highways and arterial roads. So the key insight, this range is completely unaffected by the fog or rain, unlike human vision, which is a fundamental safety advantage here. So the dashboard safety overlay classifies the alerts into 4 levels. Warning 1 is the collision imminent, that triggers the under 80 milliseconds. Warning 2 is accident ahead, needs confirmation from two peer vehicles within 120 meters. And warning 3 is a traffic congestion. Warning 4 is a continuous flowing distance advisory. Each has the guaranteed latency budget. So here there are 4 different types of warning messages are over there, and the next is without fixed roadside unit validators, we elect the mobile validators dynamically. So vehicle scored on trust, mobility, stability, compute the capacity and connectivity. Validator sets are stable for 30 seconds. 30 seconds epoch, and all the trust evidence is cryptographic sign at its secure, so relaying nodes cannot tamper with it. So we evaluate this in Venus, Ominant plus plus, and Sumo across 3 fully roadside unit free scenarios: a rural highway, uh, a dense urban grid, and low visibility emergency scenario with dense fog and tunnel. Every warning type meets the budget in every scenario. Warning 1 average is 62 to 72 milliseconds against an 80 milliseconds budget. Urban chaos runs slightly higher due to the channel congestion. Interestingly, the fog scenario performs between rural and urban because slower speed in fog means denser the shorter hopes. So connectivity holds above 95% once the density crosses that 13 vehicles per kilometer threshold, matching theory within 5% on the security side. Our infrastructure approach detects attacks at 91.4% accuracy versus the 94.3% for the roadside unit baseline. That 2.9 point gap comes from the brief trust propagation gap during the validator's handover. which we address in our future work. This table summarizes the full trade-off. We give up a small amount of detection accuracy and scalability, but gain complete roadside unit independence and an entirely new capability, the low visibility dashboard warning system. So honest limitation, spectrum interference with in-vehicle system, potential SSID linkability despite the rotation, validators churn when vehicles exit a zone, a driver distraction concern with continuous alerts, and 5 direction forwards, 5G slide links for sub 10 milliseconds alerts, then augmented reality head-up display, machine learning based validator prediction, multi-model mesh with UAV and formal verification. So to conclude, infrastructure free vehicle to vehicle mesh architecture turns every vehicle existingly Wi-Fi radio into infrastructure and extending trust aware safety anywhere roadside unit deployment is not feasible while expanding effective driver perception up to 50 folds in fog. Thank you. Thank you.
May I ask something?
Yes, ma'am, please.
Yeah. Please go to the slide number 6, ma'am.
Slide number 6. Yes, ma'am.
Can you please more focused on how you are evaluating the trust? I'm not clear with the formulas that you have explained.
Okay. For trust, we are using actually this active beacon response
Why there
protocol.
is a need of a trust score, whatever you are computing? Any real-time scenario of the case study you can match up with so that it will be easy to you to explain.
Actually, with the help of blockchain smart contract, we are trying to implement the security over here. So validators, every vehicles, and it is acting as a validators for implementing the security over here.
I think Bitcoin smart contract is not used for that smart contract. It will be a different concept which will be used whenever we are designing. How it will be applicable to your research area? Can you elaborate on the same?
When vehicle on the highway, vehicles are moving from one network to
Because
another.
mostly I think you are focusing on the fog computing, right?
Yes, ma'am.
So these are the two different things. One it is a cloud computing and the another one it is the blockchain that you are talking about. So what kind of the issues that you have identified in the fog computing so that it will be required to be go for the blockchain?
Only for security purpose, I am thinking about the blockchain. But whatever is the work is over there. So one vehicle when moving over the highway with high speed, so they are continuously changing the network topology, and at that time it is very difficult to communicate with that means high mobility over there. So the latency issue over there and network communication issues are there, and
How
due
you are
to
resolving the communication issue?
so
Because
here, in this research work, I propose that every vehicle working as a two concept, access point and station. So when we talk about the access point, so every vehicle Wi-Fi radio is here. Every vehicle access point and station. So every vehicle is communicating the vehicle which is behind it and the vehicle which is ahead of it. So in that way, own Wi-Fi network is formed and the chain is maintained by V1 to Vn.
and how your system it will be work when there will be the bad weather conditions?
So actually, in bad weather conditions, uh, visibility is not that much clear, and the drivers are facing the problem, and that's why there are the issues over there.
If you will not get the connection, then there will be the no issue of visibility. No? If there will be a bad weather condition, the condition could be anything, then how your system will work?
Here, actually, each vehicle is implementing its own. We are not connecting with any extra infrastructure or roadside unit. So each vehicle is connecting with the vehicle which is ahead of and which is behind that. So in that way, the network connection is maintained, or for
And
communication.
why you are using only the mesh topology? If you'll go through the hybrid topology, then your system will work.
Mm, no, mostly I studied on this mesh topology.
Because you are focusing on the core on the roadside. If there will be a truck, car, and that on the devices you are analyzing.
Yes.
Yes.
Yes, ma'am.
I would suggest in that rather than the blockchain, if you go through the federated learning concept, it will going to give you a good approach to the work that you are being done. So it is very important. You can go through it and you can think on it also. It will going to be helpful.
Okay, ma'am. Definitely, I will think about
Yeah.
this and I will study it on it.
Thank you.
Thank you, ma'am.
All right, thank you so much. Moving on to the next presentation. Next up, we have Salman Dhakka, who will be presenting AI-powered hybrid framework for UPI fraud detection. Salman, you may now begin. Is Salman or any of his teammates present in the meeting? All right, in that case, we move on to the next. Okay.
Ma'am, hello.
Yeah, hello.
Yeah. I am from Salman's group and I'm presenting.
All right, okay, you may continue.
So our project title is AI-powered hybrid framework for UPI fraud detection. Good morning, everyone. So this is a group and this will be the flow of the project slides. Now, the unified payments interface has fundamentally transformed digital payments in India, processing an astronomical 10 plus billion transactions every single month. It is a global benchmark for instant real-time mobile payment ecosystem. However, this massive velocity and rapid scale have increased an attractive playground for financial fraudsters. The core challenge we face today is that as payment volumes grow exponentially, the sophistication and frequency of security threats are scaling just as fast. So it's a problem statement. The problem is to put things into perspective. UPI transactions reached 74 billion in 2023 alone, bringing a strategic 85% year-over-year increase in fraud cases, accounting for losses exceeding 1,400 crore. The sheer speed of adoption has completely outrun traditional security infrastructure. The current gaps are the legacy fraud detection setups rely heavily on static rule-based system. This creates a massive gap. They suffer from a false positive rate exceeding 40%, which frustrates legitimate users. Furthermore, standard machine learning models lack sub-second real-time interference and they completely fail to stop advanced social engineering schemes. So we've done this literature survey. In that, we have found that the first paper uses a random forest with smooth. While it handles data imbalances well, it treats transaction as isolated events and completely lacks static graph-based context. Second paper uses KNN and PCA, which relies entirely on static features and sequential or behavior variations over time. And the third UPI fraud detection using ML focused on gradient boosting, but had no mechanism to synthesis rare or novel fraud scenarios. These are the other papers. So one used introduced CTGAN for tabular data synthesis, but it is an exceptional data generation model. It is not inherently designed to handle interconnected transaction network structures. Then finally, the 2020 paper explored GNN. GNNs are great at relationship mapping, but they ignore the temporal step-by-step sequential behavior of individual users. So in our system, we have found these goals and objectives for a project, that is to develop hybrid model to combine these all structural networks mapping with sequential learning, integrate advanced machine learning algorithms seamlessly, ensure real-time detection capabilities to block fraud minds transit, then build a scalability to handle millions of transactions, drastically reduce false positives to protect user experiences, and ultimately achieve the high accuracy against both and known and novel fraud types. So the phases in which our project was developed. In the first phase, data collection, we gathered anonymous real-world UPI dataset alongside simulated fraud patterns to ensure complete coverage. Phase two, we did processing, data cleaning, normalization, and engineered into spatial temporal features. We balanced the heavy skewed target using the SMOT technique. Then in phase three, model development, we constructed our core hybrid framework combining GNN, LSTM, and CTGAN within an ensemble learning environment. In the testing and validation phase, we injected explainable AI using SHAP and LIME tools, evaluating our system comprehensively using precision, recall F1 score, and AUC ROC curves. With our hybrid system architecture, in that deep learning module, first raw UPI transactions mapped into a complex UPI transaction graph, a graph neural network evaluates the relationship network using attention mechanisms to locate hidden structural patterns. Then simultaneously, an LSTM network tracks the transaction sequence behavior over time to detect hidden shifts in an individual user's habits. Then GAN-based fraud synthesis, it is used to counteract the lack of real-world fraudulent data as UPI data set is scarce. So we use CTGAN layer to simulate and synthesis rare or entirely novel attack variations, keeping our system proactive. Then in the ensemble integration layer, finally, predictions are combined using weight and voting and stacking to balance out mistakes, maximizing the final accuracy while driving false alarms down to an absolute minimum. There's a system capabilities, that is deployed architecture provides 6 production grade system traits, real-time monitoring, continuous surveillance running at sub-second latency, pattern recognition, deep identification of recurring fraud signatures across complex networks. Anomaly detection is flagging sudden behavior deviations from baseline user profiles. Risk scoring, assigning dynamic multi-indicator threats score to every incoming transaction request, and alert generation, automated instant notification dispatches to security control centers. And last is the transaction variation. It triggers the multi-layer authentication, checks for suspicious high risk scores. The software and the technologies, for our technology stack, we choose Python as a primary foundation. The deep learning architecture is powered by TensorFlow and Skitlearn for our core GNN, LSTM, and CTGN operations. The infrastructure leverages Flask and Django for our application backend. Then it's connected to PostgreSQL and MongoDB for hybrid relational transactional storage. The entire ecosystem is structured to deploy smoothly on AWS or GCP cloud services using real-time UPI AI integrations. This is our project planning Gantt chart. To keep our implementation organized, we mapped out a structured 6-month roadmap. The month one, we dedicated entirely to requirements gathering and in-depth literature review. In month two, data gathering, sorting out privacy concerns, and pre-processing workflows. Month three and four, core architectural coding, model development, and training process. And month five, a full system integration, pipeline verification, and automated testing. Month six, we dedicated to gathering the final evaluation metrics, tuning hypermetrics, and finalizing documents. These are some of the implementation screenshots of our project. This is the project home page. Then this is the model training dashboard where we put the data set and train it. So these are the training evaluation metrics, the graphs that were constructed. And this is the explainability dashboard, which is SHAP and line. It explains the project. The model training dashboard, it serves as a command center during development, giving us real-time graphical visibility into training and validation loss curves, metric growth over training approaches, and hyperparameter tuning distributions. This ensures we can precisely monitor convergence patterns, protect the network from overfitting, and continuously verify our model stability. uh, Explanatory dashboard. A classic issue with deep learning models is the black box problem. Solve this, our explanatory dashboard implement SHAP values to expose the feature importance driving our model's logic. It shows a transparent breakdown of exactly why a specific UPI transaction was marked as suspicious. This capability provides critical auditable trust required by modern banking regulators and fraud analysts.
Excuse me, I'm sorry to interrupt. You have 1 minute left.
Then our hybrid model achieved outstanding verifiable benchmarks during testing, which achieved a global accuracy rate of 98.7%. Precision stands for 97.2%, and recall as 96.8%. F1 sits firmly at 97%. We record exceptional ROC AUC score of 0.994, providing superior class discrimination capabilities. Most importantly, compared to traditional baseline models, our hybrid architecture outpaced conventional ML systems by a solid 12% to 15% improvement across every single metric while successfully cutting down rule-based false positives by 40%. Then breaking down our empirical discoveries into specific categories by fraud types, account takeovers represent the highest threat vector at 35%, SIM swaps at 28%, phishing at 22%, and transaction manipulation at 15%. Our framework secures a 96.8% success rate on known patterns, a high 94.2% on newly emerging mutations, maintains an excellent 91.5% accuracy even on completely unencountered zero-day fraud attempts. We in false positives, we achieved extremely low friction rates, registering a minor 2.1% false positive rate on complex high value transaction, 1.4% on recurring bills, and a near negligible 0.8% on a daily standard transaction. To conclude, we have successfully demonstrated an end-to-end hybrid solution, achieving 94.7% general operational detection accuracy with sub 200 ms real-time pre-processing latencies while driving down overall false positives by 67%. We manage data embellishing using smooth and integrated robust explainability. Then our future scope is that we intend to implement blockchain networks for tamper-proof audit trails, utilize federated learning to preserve user privacy across competing banks without exposing raw data, and scale our system modules to monitor cross-border international UPI transaction. And these are the reference research papers which supported our primary engineering publications, including work on CityGAN and Neuro IPS 2019, graph neural networks, etc. Thank you.
Dr. Varagdi, if you have any questions, you may ask.
Wait 1 minute.
We'll move on to the next presentation. Thank you, Sonal.
Thank you.
All right, so next up, we have Abhijay Bishnoi,
Yeah,
who will be presenting
sorry for the
AI-based
interrupt.
traffic.
Yeah,
All right.
yeah, we can continue with the next presentation.
Am I
All right.
audible?
Thank you.
Audible.
Next up, we have Abhijay Bishnoi, who will be presenting AI-based traffic surveillance for violation detection and density analysis. Abhijay, you may
Am
now
I
begin the
audible?
presentation. Yes, you're audible.
Okay, thank you for the opportunity. I'll be sharing my screen. Okay, so hello everyone. My name is Abhijay Bishnoi, and today I'll be presenting our research on AI-powered traffic surveillance system using YOLO V8 and optical flow. So, traffic violations such as overspeeding, riding without helmets, and signal jumping and lane violations are increasing everywhere. And monitoring these violations manually through CCTV cameras is extremely difficult because every single operator cannot continuously monitor multiple video feeds, and the traffic hawaldar also cannot surveillance every vehicle and every second. So our objective was to develop an intelligent traffic surveillance system that automatically detects traffic violations in real time, estimates vehicle speed, analyzes traffic density, and generates evidence for legal enforcement. Our system combines YOLO V8 for object detection, optical, optical flow for speed estimation, and a modular cloud-based architecture for deployment. So moving on to the second slide, we have the challenge. Why do we need such advanced traffic surveillance system? So before discussing the solution, let us find what's the problem. Traffic, sur- Traditional traffic monitoring depends heavily on human operators watching CCTV footage. This process is slow, time consuming, and often inconsistent because humans can easily miss violations, especially during peak traffic hours and bad weather conditions. Existing surveillance system generally focuses on only one type of violation and cannot monitor multiple violations simultaneously. As traffic volume continues to increase, there is a strong need for an intelligent automated system that works continuously without human intervention. We can see here. Moving on to the third slide, what methodology I have applied on this research. So the step one is data collection. CCTV videos collected from traffic intersections. These videos were converted into individual frames. The frames were then manually annotated to identify traffic violations. Separate datasets were prepared for two-wheelers and four-wheelers to improve detection accuracy. Then the step two is object detection. And object detection was conducted using YOLO V8. This detects vehicles from live CCTV footage by placing bounding boxes around them. It identifies vehicle categories and traffic violations with high speed and accuracy. The reason we selected YOLO V8 is because it provides an excellent balance between speed and detection performance, making it suitable for real-time surveillance. Moving on to the fourth slide, we have step three. The step third is speed detection. We have conducted speed detection using optical flow, and instead of using any expensive radar, we estimated using optical flow. Optical flow measures how an object moves between consecutive frames. So, using this motion information, the system estimates the speed of each vehicle. If the estimated speed exceeds the predefined speed limit, the vehicle is automatically flagged as overspeeding. So the fourth step is traffic detection density analysis. Sorry. The system counts the total number of vehicles present in each frame. This helps us measure congestion levels and study how traffic density affects violation frequency. Such information can also help city improve traffic management. And the fifth step is alert system. Alert system, whenever a violation is detected, the system automatically captures evidence. It stores the vehicle image, timestamp, violation type, and short video clip of the violation. These alerts can then be forwarded to traffic authorities for further action. Finally, we have deployment. Deployment on edge devices that the admin can administer. Also, it is deployed on edge devices while storing information securely on cloud servers. It can also integrate with police databases to identify repeat offenders. Moving on to the system architecture, there are five layers of this model. Our system follows a modular five-layer architecture. The first layer is data acquisition, where CCTV cameras provide live video streams using OpenCV. The second layer we can see is AI processing, where YOLO E8 performs object detection and ByteTrack performs multi object tracking. And the third layer is the logic layer, which detects violations, manages regions of interest, estimates traffic density, and applies traffic rules. The fourth layer is data persistence, which is conducted using PostgreSQL, stores detected violations, alerts, and user accounts and system configurations. Finally, the presentation layer consists of a React dashboards that display live camera feeds, heat maps, and reports and violation statistics. Moving on to the next slide, the results. Now, let us discuss the results. Our proposed system detected multiple traffic violations in real time. The system achieved processing speeds of approximately 20 to 30 FPS frames per second, which is suitable for live CCTV surveillance and cameras. It maintained good detection accuracy even under challenging conditions such as heavy traffic, rain, and low light environments. An important advantage is that the system automatically generates evidence for each detected violations, significantly reducing dependence on manual monitoring. Now, I would like to show you some sample output of the work. Here we can see that a red light violation is being done, and here we can see in this image that this man has not worn a helmet, so it is detected it. These are some of the statistics that I would like to share. And this slide presents the statistic output of our traffic surveillance system. The YOLO V8 model processes each video frame and then detects different vehicles categories such as cars, buses, and trucks, for example. And one example, we can say that there are 27 cars, 3 buses, and 2 trucks, where giving a total of 32 vehicles. The system also records the processing time for each frame. Pre-processing takes about 8 milliseconds. Post-processing takes about zero point 0.8 milliseconds. And after initialization, these results demonstrate that our system can accurately detect and count vehicles while operating efficiently enough for near real-time traffic monitoring. Also, now moving to the next slide, we have advantages of this. We have real-time monitoring compared to traditional surveillance systems. Our proposed solution provides several advantages. Detection accuracy is significantly higher than manual observation, of course, and evidence is collected automatically, making legal enforcement easier. The cloud-based architecture makes the systems scalable for smart city applications. Overall, the system reduces manpower requirements while improving road safety. Moving on to the next slide, we have limitations. Like any AI system, our approach also has certain limitations. For example, performance may reduce during extreme weather conditions such as heavy rain or fog, as it is mostly dependent on camera feeds and CCTV footages. Also, collisions in heavy traffic. Vehicle collisions in dense traffic can sometimes affect detection accuracy. Nighttime detection is still challenging because of poor visibility. Moving on to the next slide, we have future roadmap. For future work, we have divided our roadmap into three phases: the near term, mid term, and long term. In near term, we plan to integrate automatic number plate recognition, e-challan generation, improved speed estimation, and pedestrian safety detection. In the midterm, we have aimed to deploy the system on edge AI devices such as 5G networks, along with federated learning and multi-camera vehicle re-identification. And the third long term, we envision predictive traffic congestion management, emergency vehicle prioritization, vehicle to everything communication, and adaptive smart street lighting. In conclusion, this research demonstrates that artificial intelligence can transform traditional traffic surveillance into an intelligence, automated, and scalable traffic management platform that supports safer roads and future smart cities. So, thank you for your attention, and I would be happy for any questions.
Yes. Nice presentation, and I think your project is also too good. Can you please tell me it will going to be mapped with which SDG?
Can you please repeat now?
This particular project, it will going to be mapped with which SDGs of Sustainable Development Goals?
Ma'am, the smart city projects like you know reducing the manpower and everything.
In that already the
Main goal is to reduce the manpower and the corruption of the manpower, we can say, and the dependence to the artificial intelligence,
uh,
which can record evidence as well as everything. So it's in a presentable form.
one question: if your traffic is dense, for example, if
Yes,
I'll take the real-time example of Delhi or Mumbai,
yes,
so
ma'am.
how your system it will work? Because whatever may be the images and the result that you have shown in that,
Yes,
because you have tried it on the data set, right? Go to the slide number 7.
yes, ma'am.
So if you're going to be considered the traffic, it is in the proper format and the proper way. Every means vehicle is following the proper lines and all. If your traffic is dense, if I'll take the real-time example of Delhi, then how your system it will work?
Yes, ma'am. That's a limitation of one of the limitations of YOLO V8, and
Okay.
we can use YOLO V version, the next version, in
Hmm.
which they can say that you have a better approach to this.
Whatever may be the system that you have developed, have you think about ki, if it is not following the guidelines or the rules which that after detection, so have you link up any penalty will be just say if I'm crossing the signal or anything, automatically will receive the message you have violated the rule.
Ma'am,
This
that's in a future roadmap, that each alarm generation and everything we can
so only the
do
you are
that. It
classifying and
was
the object has been detected right in your system now.
Yeah, yes, ma'am. It was just for the CCTV footage. We have
Mhm.
CCTV footage, and then we have placed in that Python program,
Okay.
and it was just a basic one.
Have you tried any consultancy for the same?
No, ma'am.
It's or any real-time data that you have captured from the camera which has been there on the traffic signal. Later on that any real-time data have you tried?
Yes, ma'am. It was this one where
Mm-hmm.
uh, where I have taken this CCTV footage from YouTube, and then I have tested on it, and we can see that these two vehicles were moving more than the speed limit, so it detected that.
No, fine.
All right, we'll now move on to the next presentation. So, next up, we have Arundhati P, who will be presenting Dual Pathways of Mental Health Podcast Characteristics Influencing Stickiness Through Commitment and Parasocial Processes. You may now begin your presentation.
Ma'am, are you audible?
Yes, you're audible.
So, good morning. So, my research topic is a dual pathway of mental health podcast characteristic influencing through commitment and parasocial process. This research investigate how mental health podcast characteristic influence long-term audience engagement through behavior commitment and psychological attachment. So, as an introductory, we can see mental health podcasts have become an important digital health communication tool. They combine expert knowledge with personal storytelling, making mental health information more accessible and helping reduce stigma. Although podcast users is increasing, many listeners discontinue after a short period. Therefore, understanding what drive long-term engagement or products podcast stickiness has become an important research problem. As per the previous studies, they were suggesting that podcast characteristics such as trustworthiness, expertise in interaction, attractiveness, and uniqueness improve listeners' engagement. Podcast commitment presents behavioral attachment. Podcast interaction is the perceived interaction with the host. Parasocial relationship is the deeper emotional bond developed over repeated listening. These variables together contribute to podcast stickiness, which represent long-term engagement. So, based on the conceptual model, our study was focusing on the stimulus orgasm response framework. Uh, the podcast characteristic act as a stimulus inside the organism. We propose two engagement mechanism. The first is the behavioral pathway explained through the commitment theory, uh, and the second is the psychological pathway, which was explained through the parasocial interaction theory. Finally, both pathway lead to the podcast sickness, which is our response. As per the uh, uh, literature review, we find out that previous studies mainly examined behavioral commitment and parasocial relationships separately. Most research focused on short-term outcome, such as listening intention rather than long-term stickiness. In addition, the SOR framework has rarely been applied from the dual pathway perspective in podcast research. Therefore, this study proposed an integrated dual pathway engagement model. The methodology of my study is based on the quantitative cross-sectional research design. Data collections were collected from 320 mental health podcast listeners across South India using snowball sampling. Data were analyzed using SPSS version 2025, correlation, regression, exploratory factory analysis, and mediation analysis were performed to test the proposed hypothesis. And finding of my study is podcast characteristic positively influence podcast stickiness. Podcast commitment significantly mediate the relationship. The parasocial interaction and parasocial relationship also secondly mediate the relationship. And finally, our integrated model explains 66.7 percentage of variance in the podcast thickness indicate a strong explanatory power. The future scope and limitations of my study is the future study can validate this model using longitudinal and cross cultural research. Research can include AI based personalization like empathy, trust, and social presence. The limitations of my study can be noticed as we believe that integrating these two pathways provide a more comprehensive. Limitations include the cross-sectional design, convention sampling, and reliance on the self-reported data. So, as a conclusion, our study demonstrates that long-term engagement with the mental health podcast is influenced by both behavioral commitment and psychological attachment. So, thank you.
Yeah, thank you, ma'am. Can you correlate with whatever with the observation that you have done using your research with any real-time scenario or any real-time case study?
Uh,
Have you give any example which will be related to that? Or have you mapped with any of the case study which is related to the thing that you have?
we are
Um,
delving to the qualitative part, focusing on 5 podcasts, which were based on the YouTube rating and the views rating. We were looking to the famous Raj Sharma's video, and uh, so as a qualitative part, we were thinking to do like that. In this research, we were mostly
how much
focused.
data set you have collected?
What?
Data set you have collected for the same?
320.
Okay. In the fourth factor, emotional connection, build locality, how you're identifying the same? Go to the upper side. Stickiness that you are saying, the means commitment, that all the factors how you are meditating, means how the kind of meditation that you are providing. Have you set any value for the same? So for example, if I'm saying ki if the range it is from 50 to 60, then it will require some meditation. So how any range specific that you have decided?
Not yet, not yet. We didn't decide it.
So only you have done the statistical and the study on this all these characters,
Yes, yes. Only we done like that.
because it goes to the emotional intelligence too, no, right? So in that, what kind of techniques that you are going to be use?
Uh, we will be doing both qualitative and quantitative mixed analysis.
Means how you are evaluating the quantitative mixture. If you're talking about quality, it's okay because you will get all the information, but how it will be handled, which kind of technique have you analyzed for the same you are going to use? No? Hello?
Real meditation.
Okay. Okay, fine. Yeah, ma'am, we can proceed with the next.
All right, thank you
Okay.
so much. So now moving on to the next presentation, we will have Sheetal Patil, who will be presenting dynamic hand gesture recognition for deaf and dumb people using deep learning approach for Indian Sign Language, a hierarchical multimodal attention transformer. Sheetal, you may now begin.
Yes, ma'am. Am I audible?
Yes, you are.
Okay, 1 second. I will share a screen. Screen is visible, ma'am?
Yes, it is.
Okay, thank you. So, good morning to all, respected session chair and participants. Myself, Shital Patil, a research scholar from Department of Computer Engineering and Bharati Vidyapit deemed to be university. Today, I am presenting our research paper titled Dynamic Hand Gesture Recognition for Deaf and Dumb People using Deep Learning Approach for Indian Sign Language, a hierarchical multimodal attention transformer. Now, the next one, the contents of today's presentation, introduction, objectives, problem statement, literature review, proposed system and architecture, result, conclusion, and references. Introduction. Communication is one of the basic human rights. However, nearly 70 million deaf and hard of hearing people worldwide really depends on the sign language. Now, what is the meaning of sign language? Sign language is a combination of our body movements, facial expressions, and the hand movements. And such type of peoples are using a sign language for their communication purpose. Recent development in a computer vision and deep learning have significantly improved sign language recognition system. Most existing research has focused on only American Sign Language because it consists of the huge data set and it gives 93% of the accuracy. But the drawback is that there is a very less work is done on Indian Sign Language. There are a number of challenges are faced for the Indian Sign Language recognition. The challenges are continuous hand movements are present in Indian Sign Language. That means continuously hand movements are present at the time when we communicate with sign languages. Then different body postures, facial expressions are included in Indian Sign Language. Such in American Sign Language, only the hand movements are present. Limited training data set and real-time processing requirements. So such type of challenges are focused on Indian Sign Language. So my research work is only focused on Indian Sign Language. The next one, objective. Uh, Next one, sorry, problem statement. The communication gap between the deaf and individuals are the general public remains a major challenges because most people cannot understand Indian Sign Language. Limited, there are the several limitations are present. Limited recognition accuracy, difficulty recognizing dynamic gesture. Now, the next one, sensitivity to lighting variations, complex background, motion blur, different hand sizes, different signing speeds. So, for the above problem statement, we need an intelligent framework that provide high accuracy, faster processing, and reliable recognition for the real-time application. Now, the next one, objective. Improve a gesture recognition accuracy. In my first objective, here I focus on a dynamic hand recognition. Now, what is the meaning of dynamic hand recognition? Here I take the hand movements. That means that particular gesture consists of the motions. Most of the existing work is only focused on the static recognition. So the first one objective is here I am focusing on the dynamic gesture recognition. The next one, enhance image quality of the signed images. So to take for every sign we have a reliable images. For that, here I am using a different data acquisitions. The next one, reduce computational complexity. Then there is a faster interference, develop an effective spatio-temporal framework. Now the next one, literature survey. So here the first one paper, they are only focusing on the dynamic hand gesture data set. The key findings are combining CNN model they are using, that is CNN and LSTM. But the limitation is that there is a very performance is very slow. They give a high computational complexity. The next one, dynamic gesture videos data set is used. That means they are using a videos for that particular data set. Then next, there is a effective capture spatial and temporal dependency, improving classification accuracy. Here, limitations is that required a large amount of training data because they are using the videos, and the interference speed is very low. The next one, Indian Sign Language. There is one paper I found that from the Indian Sign Language dataset, improve temporal learning and recognition performance for Indian Sign Language gesture, but they cannot capture the sign movements which is on a different background. They have to take a constant background which is on which is of a red color or a black color. In front of that particular background they capture the signs. Then next one, last one is there is a public gesture data set is present. So they take a combination of American data set and the Indian data set for only a number detections. Then there is also limitation. There is a very less data set is present for the numbers also. Now next one, proposed methodology. So in my proposed methodology, total 6 phases are present. The first one called is a video acquisitions. So what is the meaning of video acquisitions? The system accept an input video of Indian Sign Language gesture. Each video is uniformly sampled into a 64 frames to preserve a temporal information. So first of all, here I take a videos, and that particular video is divided into the 64 frames. It is work like a one image. Then next one, data processing. Each frame is resized and normalized. After taking that frame, again we have to apply a different technique. That is the first one, rotation, scaling, frame dropping, and noise addition to improve the robustness of that particular frames. Then next one, third one stage is that multi-model feature extraction. The model extract two features. The first one feature is a pose features and the second one is called RGB features. So the pose feature inside here we differentiate that body movements, left hand movements and the right hand movements. After that RGB features are present related to the images. Then hierarchical transformer encoder, there are three levels are present in that. The first one level is only for the learns finger articulations. The second level learns body posture, and the third level captures the temporal relationship across the complete gesture sequence. That means it take a complete body movement, hand movements. The next one, cross model gated attention fusion. This model combines pose features and RCB features using gated attention. When RGB quality is good, the model relies more on RGB. When the lighting is poor, when there are different backgrounds are present, it also overcome with the help of this stage. Then next one, gesture classification. This is the final stage. Here they can present their gesture in the form of voice or in the form of, we can say that, the speech. Then next one, this is the flow of my system. The first one, there is a video frames. After that, three phases are present. The first one is for the hand cropping. The second one is called hand key point detection. Then optical flow computation, hierarchical multimodal. Then there is a gesture classification. After that, they give a final output. Then next one, this is the result. So here I compare my system with the related to a data set. Right now this result is only focusing on the data set because there is no any inbuilt data set present for the Indian Sign Language. So for that, here I take a two types of data set, include the images of 263, after that 50, and there is a third one data set in that 100 sign images are present. So depends on that, this is the accuracy here I got. Here I take the next one parameter, that is f frame per seconds. Then the conclusion is that proposed system is focused on the hierarchical multimodal attention. So it combines the pose landmark and the RGB hand features, uses hierarchical transformer learning, improve temporal modeling through attention mechanism, achieves 95.8% recognition accuracy related to the data set, support real-time deployment using the lightweight HEMAT light model. So these are the references. Thank you.
Ma'am, do you have any demonstration on the same?
No, ma'am. Right now, demonstration is not present with me.
Then how you are going to be propose the model?
Right now, I'm taking only, ma'am. I'm focusing on my first two the phases, that is data acquisitions and pre-processing. So for that only, I'm focusing right now for this conference.
Because you are talking about the accuracy, then you have achieved.
Accuracy related from the first model is with me. That means only I can pass that particular videos, converted into the frames, and after that pre-processing is applied.
Because to convert the video into the frame, it will be an easy task, ma'am.
Yes, ma'am, because I'm focusing on the dynamic hand gesture, and in that there is the movements are present. So that movements are not captured by the image. That's why I'm taking the videos.
Have you tried first of all on the static hand gesture?
For the static hand
Because
gesture,
data sets are available, means most of the data sets are available.
yes, for the static hand gesture, I'm taking only the alphabet. That in our A to Z alphabet, there are two alphabets are present, which is focused on the dynamic. So for that static image, I am taking the alphabets.
Okay. Which two alphabets are available?
A, B, C, D, such type. And for the J and L, they are using the movements.
They are using the movements. So it will going to be achieved with the framework because if you talked about that, I think you have not used the GNN. No? You are dealing with the
No, ma'am.
CNN.
Right. Yes, yes. Right now, I'm only using the CNN. So let's see if static images they capture properly. Then I'm using that particular dynamic hand movements for that capital letters.
Yeah. If
Yes.
you're going to be used in that graph transformer technique or the GNN, it will be the more, or the spatial temporal transformer if you're going to be used. I
Yes.
think it will going to give you the good accuracy as compared to the CNN, because in case of the CNN, most of the time whenever the regression you will going to be find out now, So it will
Yes,
going
ma'am.
to be not evaluating the proper parameter, that is F1 score later on whenever you are calculating further. So it will going to
Okay.
create
Okay.
that. So if you are
Okay.
going for the dynamic gesture sequences, it will
Okay.
be better ki rather than the CNN, you can go for the Spatio or you can use the GNN. So it will
Okay,
be
ma'am. Okay.
easy.
Definitely, I will take your suggestions. Thank you, ma'am. Thank you.
Yeah, yeah, yeah.
Thank you.
Okay.
All right. Thank you so much. So we'll move on to the next presentation. And next up, we have Diksha Negi, who will be presenting ICT-enabled work environment, emotional labor, the emerging trends and research themes, a bibliometric analysis. Diksha, you may now begin.
Hello, audible?
Yes, you're audible.
Thank you, ma'am. Good morning, everyone. I am Diksha Negi, a research.
Excuse me, Diksha, your voice is breaking out. I believe there's some issues with Diksha's internet. So in the meantime, we'll move on to the next presentation and we'll circle back to her later. So now we'll have Rahul Dhaigare, who will be presenting impact of perceived interoperability issues on the brand loyalty and subsequent purchasing behavior of Indian smart home users. Rahul, you may now begin your presentation.
Yeah, am I audible, ma'am?
Yes, you are.
So let me share my presentation. Is my presentation visible, ma'am?
Yes, it is.
Yeah, thank you. So good morning, all. I'm Dr. Rahul from Symbiosis Institute of Management Studies. Along with my two co-authors, Dr. Shrikant Gharge and Dinesh Gore, will be presenting a paper titled Impact of Perceived Interoperability Issues on Brand Loyalty and Subsequent Purchasing Behavior of Indian Smart Home Users. Now, the context is uh, we have been witnessing the technology era, rapid changing technology, and India is no behind. So, if you look at the IoT related technological advancement, Indian consumers or the home buyers now slowly turning towards the smart homes. So, what is this smart home? There are some devices which are being connected to the IoT through IoT, and they are being used in the households. So these are getting, the rapid penetration in cities like tier 1 and tier 2 cities like Delhi NCR or Mumbai, Pune, etc., Chennai. But what is happening of late is if you go to purchase different devices, you will find different brands. And now moving onwards, when the people try to integrate their home or domestic devices, they are finding it difficult. So we can talk about the smart speakers, smart bulbs, curtains, plugs, other devices, your watches. They are not getting integrated seamlessly. And what is happening? Indian people are getting frustrated because of this. Now, from technological point of view, there are a few studies available, but from psychological and behavioral perspective, there are not much literature available. So we tried to find out through the empirical study, like what is happening if there are different brands. People are actually willing to make advancements in their living experiences, but because of different brands, they are facing problems. So one of the effect what we can call is walled garden effect. So there are devices available, but to add some more devices to it, the brands are asking the consumers to go for the same brand. And if you look at the Indian people, their perceived behavior, or mainly the price sensitivity, they're trying to go for some cheaper devices which they are not able to get, and then it is leading to the frustration kind of thing. So for us, the primary objective is to evaluate the impact of this perceived interoperability issue on the brand loyalty, and then further to investigate. uh, we are assuming that this brand loyalty is getting diminished, so we are trying to investigate how this diminished brand loyalty influences the subsequent purchasing behavior. For this, we have formulated four hypotheses. So first hypothesis is perceived interoperability issues have a significant negative impact on the smart home users' brand loyalty. So PII leading to negative brand loyalty. Further, the brand loyalty has a significant positive impact on subsequent purchasing behavior. So this brand loyalty leading to the subsequent positive impact. Third hypothesis is perceived interoperability issues have a direct and significant negative impact on subsequent purchasing behavior. So again, PII leading that negatively leading to the subsequent purchasing behavior. And this fourth hypothesis is kind of a mediating hypothesis, and it talks about brand loyalty mediating the relationship between the PII and the SPB, subsequent purchasing behavior. Okay. Uh, from literature, we came to find out that there are three different main themes. One is leading to the TAM, technology acceptance model. Second, leading to the brand loyalty, and then which is in the third context of smart homes, which is upcoming area in Indian context. In foreign countries, you will find a lot of literature, but from Indian perspective, Indian context, we have got a limited literature on this. For this particular study, the research design, we approached mixed method, qualitative and quantitative. For quantitative, it was a cross-sectional survey from different cities, from different demographic people. And for the qualitative studies, we had 20 in-depth interviews with the people. For this quantitative study, we took the convenience sample of 450 people, for which we had actually circulated the questionnaire to around 520 people, but received responses from 450. The people were, as I've mentioned earlier, they were from the cities of Delhi, NCR, Mumbai, Bengaluru, Hyderabad, Chennai, and Pune. The main questions they were asked to the people about how many devices they are having, smart devices they are having. So minimum 3 devices if they are holding, then we went ahead with those people and further analysis of their responses. The sample was convenience and snowball. So for the quantitative, it was a convenience sampling, and for the qualitative, it was a snowball sampling, because as you know, Indian people actually do not they are not very much interested in answering the questionnaire mainly, or they do not want to spend a lot of time asking people about their individual preferences or the interests. So it was a snowball sampling. Those people who are interested and they are good at using the devices, they were asked, or they were you know they were reached out for interviews. So we used the 5-point Likert scale. There were 12 items in 3 different categories: perceived interoperability issues, brand loyalty, and purchasing behavior related items. And then these responses were analyzed using the SPSS. So demographic information was derived from the responses. Then we used PLSM for the further analysis, and thematic analysis was carried out on the qualitative data. This is demographic information of the respondents. 72% people they were holding either bachelor's or higher degree. 83% people they owned three or more brands in their home. 88% people they had at least one smart speaker, and so on. So after using this PLS SM model on the responses, this is the result. So the questionnaire was valid. Cronbach's alpha talks about it, more than 0.7. Composed reliability is more than 0.8, and AVE is more than 0.5. So Cronbach's alpha talks about the consistency. So whatever constructs we went ahead with, they were good for conducting the SCM on it. AV also talks about the convergent validity of all the constructs. It was good to go, and so we run the test on the data. This is the result of SEM. So this perceived interoperability issue leading to the brand loyalty and then leading to the subsequent purchasing behavior gives us the result of negative 0.528 here, and positive impact of plus 0.415 from brand loyalty on subsequent purchasing behavior, and from PII on subsequent purchasing behavior, that is SBP, it was 0.342 minus 0.340, negative 0.342, which is the direct impact of PII on SBP, and the mediating effect of indirect operability was negative 0.219.
Excuse me, I'm sorry to interrupt. You have less than a minute left.
Yeah, I am done. So if you look at all these three hypotheses, whatever hypothesis we have mentioned, so hypothesis 1, 2, 3, they were supported, and fourth was a partial because it was a indirect impact. From qualitative insights, there were three emerging themes. One was the blame game. So when we try to integrate two different brands and the people fail to connect these two or more devices seamlessly, they do not understand that there are different technical underlying protocols which are not making it easier for the people to use the devices seamlessly. But what do? Instead of looking at the technical specification, we tend to blame the brands directly. Then there is a walled garden resentment. Of course, the brands are restricting the people from using the different devices seamlessly or integrating different brands devices, and that is leading to the frustration of the users. And then reticence to expand is, of course, since the people are experiencing this kind of uh, problems or issues, the people don't want to go ahead with purchasing the further items. So they don't understand actually what are the technical specifications and requirements, but they are now trying to wait for the universal standards. That means the different devices could seamlessly integrate with others. Like for example, Apple was told to use this C type of connector, which they were not doing. So in future, if those kind of standard universal measures and specifications come into place, then probably we'll be able to experience these different devices seamlessly. So the key findings finally, this personal interoperability issue significantly erodes brand loyalty. Brand loyalty directly drives the further purchasing expansion, and this interoperability frustration suppresses the further purchases. Brand loyalty partially mediates the PII to SBP path, subsequent purchasing behavior path. Variance, not a big deal. For this research, managerial implication is these are the core product features. So the new devices, the brand should look at providing those kind of devices which would be helpful and seamlessly integrating with other brands as well. So this seamless integration is USP, which will become for the brands to sell their products more. Need to equip customers support for cross-band troubleshooting, which is not happening as of now. and they need to redesign companion app, because for different brands people have to use different apps. For Amazon it is different, for Apple it is different, for Xiaomi it is different. So maintaining and handling those different app and their features is frustrating for the people. These are the references, and definitely this research will go on, because this has got some restrictions as well, because we are talking about only the 12-point questionnaire, where we try to find out the issues of loyalty, technological adoption, and then the further purchasing behavior. But as you know, the Indian demography is completely different, the people's preferences is different, their interests are different, and then we are the price sensitive market. So probably in different demographics, the result could be different. So this will lead to the further investigation into this particular topic as well. That's all from our side. Thank you. Any questions? Should I stop sharing?
Yes, sir. Have you done the comparative analysis on all the techniques that you have done?
Not all, ma'am.
Okay. Because I think you are focused on the most, that is the few technique which will be related to the factors that it will be mentioned in the presentation. Can you please go back to the slide number 8 where you have mentioned the hypothesis?
Yes, ma'am.
So whatever the result that you are showing in this PPT, you have given, it will be supported, and the last one it will be a partial. So on what
Yes.
basis on the parameter that you have decided that all the hypotheses will be supported?
So these are the results, ma'am. Okay. So the p-value is it has to be greater than 0.001, and if you look at these values appear to be less than 0.001. So that's getting supported. This is negative. This is negative.
Because it is very minimal value, no? 0.001, it should be negligible.
So
Then
this is
how your
negative, ma'am.
hypothesis can be?
This is negative. So it is less than that.
So
So
based on that,
it is proving.
the
Yes, yes,
SPB
yes.
score, that is
This
subsequent purchasing behavior. How
subsequent
you are
purchasing behavior.
analyzing that?
So if
How you are
you have got
analyzing?
yes, say for example, if you've got some Apple product, okay, and you want a connecting device or some other device which is supporting, or say for example, you have got a smartwatch, and you
Yes.
have got say a fridge or AC at your home. So what you try to do, you try to operate this device through your watch, because now you can connect your mobile with the watch. Okay. So it is expected that this watch also should be able to operate those devices. But what is happening? These Apple devices are asking you to have the Apple devices again. Okay. You cannot operate those other smart devices like Xiaomi bulb or Xiaomi converters. So if you have got Xiaomi bulbs or Xiaomi curtains, these Apple watches are not helping, or Apple phones are not helping you seamlessly integrate and operate those devices. So this is what is
Right.
happening. So if you want to buy curtain, if you want to buy bulb which is smart, and you want to operate it through your Apple phone, then that is restricting you. So it is not
Because
driving
it
you
is not
to
integrated with each and every things,
the,
I would say.
yeah. So this is
So that
subsequent
all these
purchasing.
things
That
it was
means
not integrated.
if you want to go ahead and purchase some devices which will be adding some value into your home, but since you already have some other brand devices, then that is not, that is restricting you to buy the other brand devices. So this is subsequent purchasing behavior. Though you want to purchase, you are not able to, or you cannot buy those things, because that is that integration is not happening. So you are forcing to, you're being forced to buy the same brand items. So Apple would force you to buy Apple items only. So though you want to purchase something else, but this brand, it forces you. So this is a forced
Then you are
brand loyalty.
developing a system which can be integrated with all these things.
No, ma'am.
With the
This
one
is
of the hypothesis that you have made.
yes, ma'am.
Okay.
This is just an empirical study.
Okay, fine. Okay.
Any other question, ma'am?
No, sir. Thank
Yeah. Can I stop sharing?
you. Yes.
Thank you so much. Thank you for your inputs, ma'am. Thanks. Thank you all.
Thank you.
Good afternoon.
We'll now circle back to the previous presentation. Diksha Negi will be presenting ICT-enabled work environment, emotional labor, the emerging trends and research themes, a bibliometric analysis. Diksha, you may now continue.
Thank you, ma'am. Good morning, everyone. I am Diksha Negi, research scholar in the Department of Management Study at Graphigera deemed to be University. Today, I'm delighted to present our research title, ICT-enabled work environment, emotional labor, the emerging trends and research themes, a bibliometric analysis. So, emotional labor has been studied for many years in sectors like hospitality, healthcare, and customer service. However, today our workplaces are changing because of AI, digital technologies, and remote working. So, we wanted to understand how research on emotional labor has changed in ICT-enabled workplace. For this, we conducted a bibliometric analysis using this Scopus database. This presentation, I will briefly explain the background of the study, research methodology, major findings, and the future directions. So, moving towards the next slide. Let's first understand what emotional labor is and why it is important in today's workplace. So, emotional labor was first introduced by Arlie Hochschild in 1983. It simply means managing and controlling our emotions while interacting with others at work. Sometimes employees have to stay calm, smile, or behave politely even when they may not actually feel that way. This is what emotional labor, and it has mainly includes two strategies. The first one is surface acting, the other one is deep acting. Surface acting, where employee only displays the required emotions without actually feeling them. For example, a customer service executive may smile while talking to a customer, even if they are stressed or upset. The second one is deep acting, where employees tries to genuinely change their feelings so that emotions they express are real and natural. Traditionally, emotional labor has been studied in sectors such as healthcare, hospitality, customer service, and retails, where employees regularly interact with customers. However, the rapid growth of digital technologies and AI is no longer AI, emotional labor is no longer limited to these sectors. It has become equally important in ICT-enabled workplaces, which is the main focus of our study. Moving towards the understanding why this study was conducted. So today, organizations are rapidly adopting ICT along with AI, cloud computing, digital communications platforms, and remote collaboration tools. Because of these technology, the employee work and communicated has changed significantly. Instead of face-to-face interaction, employees now communicate through emails, video meetings, chats, platforms, and AI-assisted systems. As a result, employees are still expected to remain professional, calm, positive, but now they have to manage their emotion digitally environments as well. This means the EL is no longer limited to the hospitality or healthcare. It has become an important part of ICT-enabled workplaces. However, when we reviewed the existing literature, we found an important research gap. Most previous study focus either on emotional labor or on digital technologies separately. Very few studies examined emotional labor, how emotional labor changing in ICT enabled work environments. We also found that available research was scattered across disciplines, making it difficult to get a complete picture of this emerging field. Therefore, we conducted this bibliometric analysis to systematically map the existing research, identifying the major themes and highlights future research direction. Based on this research gap, we have developed 5 objectives to guide our study. The first objective, we wanted to understand how this research area has evolved over time. So the first objective is to examine publication trends in emotional labor. The second, to identify major research themes and clusters using VOS keywords co-occurrence analysis. And the third, to explore the influence of AI, digital platforms, emerging technology, and influencing EL. The fourth objective was to understand how EL is related to important workplace outcomes such as employee well-being and job satisfaction. Finally, the fifth objective was to identify the existing research gaps and suggest possible directions for future research. To achieve these objectives, we adopted a systematic bibliometric research methodology, which I will explain in the next slide. So this study adopted a bibliometric research proposal. For this study, we collected data from the Scopus database as the search covered publication from 2000 to April 2026 using keywords related to emotional labor, ICT, AI, digital work, and emotional recognition. After retrieving the publication, we applied Prisma screening process to ensure the only relevant study were included. Initially, we identified 274 publications like the inclusion and exclusion criteria. When seven publication was selected for the final analysis. Finally, we used VS Viewer software to analyze the data. VS Viewer had us visualize the keyword co-occurrence network and identify the major themes and cluster within this field. After selecting the final some publication, we analyze the publication trends to understand how research on EL capacity-enabled workplace has evolved over time. The graph shows the annual publication trend from 2000 to 2026. As we can see, research in this area was quite limited before 2000. Only a few studies were published during those years. However, after 2020, there was a significant increase in the number of publications. The increase indicates that research have become more interested in understanding EL in capacity-enabled workplace. One possible reason for this is the rapid adoption of AI, digital transformation, and remote working and hybrid workplace models, especially after the COVID-19 pandemic. The graph also shows that the highest number of publications was recorded in the most recent, which suggested that this is an emerging and rapidly growing research area. Overall, the publication trends confirm that EL in ICT-enabled workplace has become an important topic for researchers across different disciplines. Let's move toward the keywords co-occurrence analysis. In this, the figure shows the keyword co-occurrence occurrence network generated using VS Viewer. In this network, each circle represents a keyword and the size of the circle indicates how frequently that keyword appears in the published literature. The lines connecting the circle shows the relationship in different keywords and different colors present different thematic cluster or research area. As we can see, EL is the largest and the central keyword, which means it is the main focus of this research field. It is strongly connected with keywords such as AI, emotional recognition, digital workplaces. Also identified four major thematic clusters, showing that EL research has become interdisciplinary by combining management, information system, education, and computer science. These cluster provides a deeper understanding of how research in this field is evolving, and I will explain them in the next slide. Based on the network, four major themes were identified. The first theme is AI-based EL and emotional recognition. This cluster shows that AI is increasingly being used to understand and manage human emotions in the workplace. It also highlights important issues such as ethics, privacy, and emotional authenticity. The second theme is EL in digital education. This theme shows that the online and hybrid learning have increased the emotional demands on educators. It also suggests that emotion, including gender. The third theme is AI, emotional labor, and job satisfaction that explain AI can improve workplace efficiency, but its impact on job satisfaction depends on how organizations use technology and support their employees.
Excuse me, I'm sorry to interrupt. You have 1 minute left.
Okay, ma'am. The fourth cluster is fundamental emotional construct. Based on our bibliometric analysis, we identified five major themes: rapid growth of research, artificial intelligence as an emerging theme, its satisfaction, emerging ethical challenges. Based on these findings, I would like to conclude my presentation and highlight some future research direction. This study provides a comprehensive overview of EL research on ICT-enabled workplace. Our finding shows that EL is no longer limited to traditional service industries. It has become an important research area in AI-enabled and digital workplace. We identified four major thematic clusters, highlights the growing role of AI, employee well-being, and job satisfaction in this field. Future research should focus on the long-term impact of AI, ethical issues such as privacy, surveillance, and strategies to support employees in digital workplace. Thank you. This is from my side, ma'am.
Dr. Vayurgade, do you have any questions?
Thank you.
All right. So we'll move on to the next presentation. Next up, we have Nityaranjan Manihari, who will be presenting lightweight biotic stress detection in millets, a green tiny DL approach. You may now begin your presentation.
Am I audible?
Yes, you are.
Okay. Good morning. My name is Nityaranjan Manihari, and research scholar in the Department of Electronics, Sambalpur University, Burla, Odisha. My paper title, Lightweight Biotic Stress Detection in Millets, a Green Tiny DL Approach. Millets are highly variable climate resilient nutricereals that have sustained in human food system for over 7,000 years.
Excuse me, I'm so sorry to
Yes?
interrupt. Please share your screen.
Okay, sorry. I think I clicked that wrong button. Okay, sorry. It is visible now?
Yes, it is.
Still visible now? Okay. Yes, sir. Millets are highly variable, climate resilient nutricereals that have sustained in human food system for over 7,000 years. India leads the production with roughly 40% of global 29.3 million metric ton in the year 2024-25, spreaded by an initiative from our Honorable Prime Minister. The United Nations declared 2023 as the International Year of Millets. Among the wide varieties of millets, pearl millet, that is known as bajra, is the most produced in India, accounting for approximately 55% national total. Despite the robust nature of millets, diseases like downy mildew, rust, uh, yield loss occurs up to 80%. Need for fast accurate detection in remote field with no internet connection. Shifting for power-hungry GPUs to low power edge deployment. Hence, our method, here is the dataset we use in our pipeline, having three class, healthy, downy mildew, and rust. It is a row upload dataset from the maker Leap Chalmers, having 5,516 images. Our methodology consists of MobileNet V2 backbone and with custom residual blocks and MSDA. Here is our pipeline. The input image is given to the MobileNet V2 written backbone. Then this will go to the custom residual block. We skip connection, and then this after that first residual block, it will go to multi-scale dual attention module, and then a secondary residual block. the output will given to the classification head, then it will predict between healthy, downy mildew or rust. Here is our confusion matrix. From this, we can conclude that our model is confidently classifying between these three classes. Doing the evaluation study with the pretend mobile V2, we can see that our proposed model consistently outperforming the standard mobile V2 architecture with nearly more than 5% of accuracy. Here is the parameter of our model. Our model consists of only 0.6521 million parameter, size of 3.09 MB, and average inference latency with 18.06 millisecond, with computational cost of 0.055 giga floating point operation. To compare our model with the existing literature, you can see that most of the models are either heavyweight, and our model is close to half of the Johnson 2024 models. We also integrated external AI method like GradCam. It visualizes that model is focusing on the actual lip region rather than cheating by looking at the background. We can see that the models are confidently predicting more than 95% each disease accurately. To check as our model is not fixed to just millet, we test with the IEEE Petitog dataset containing 13 class. It also yields 91% accuracy. Here is the confusion matrix for the test set. To conclude this, our tiny DL framework provides a highly accurate, which is 98.47 accuracy, resource efficient green AI solution for real-time on-field detection of millet disease like downy mildew and rust. By optimizing a MobileNet V2 backbone with custom residual multi-scale dual attention block, the model maintains an ultra-low footprint of 3.09 MB and 0.65 million parameter, supported by external AI for reliable lesion targeting and demonstrating strong generalization capability, which is 91% accuracy on a diverse Petitog dataset containing 13 classes. This approach successfully delivers high-performance deep learning for practical edge-based agriculture deployment. Future work will be focusing on deploying this tiny DL framework onto the edge device, directly addressing the critical need for fast, accurate offline disease detection in remote millet fields. Future research can expand this lighter framework to detect additional biotic stresses and generalizing across a wider variety of agricultural crops. Here is the references. Thank you.
Yeah, sir. One question. Can you please go to slide number 10, 11? 10 and 11.
Okay. Yes. It is 10.
These are all the existing technique. Can you please tell me regarding how you have evaluated the F1 score? Which kind of mathematical computation you have done for this? These are the result that you have achieved, right? And
yes, this 98.47 is our accuracy.
Because in that the second, if you see the custom CNN, they have achieved the accuracy
this
of
also achieved.
98.86.
Yes. But our model size is,
So
ma'am, yes, this is 1.85 million parameter. We have 0.65 million parameter. This is
model profile.
Yes.
Model profile is in the sense the data set that you are using and the accuracy that you have achieved that you are telling us of.
No. That accuracy section is key. The model
that
size.
Is different. I know.
Okay, model
but
size.
the model
I'm
profile
talking
that you
model parameter. Yes, ma'am. This model parameter about the model size and parameter. I'm talking about that how much that actual word. Parameter and the size
whatever may be the
to be
existing and the
deployed on the edge device.
system.
Yes, ma'am.
Because the accuracy that you have achieved, it will be the different. And what exactly the difference between these two? Because it is the latest paper from 2024, not So it's just 26. So the technique that they have used, that you have analyzed in your system.
No,
Or,
ma'am, that particular data set they are using is not publicly available. We are applying our model onto a publicly available RoboFlow data set, the leaf channels data set, but they are using their own custom data set that is not available in public domains.
So what kind of different attributes that you are using to test that? How many attributes in your data set? Based on that, you are giving the conclusion that your proposed model is achieving that kind of things. And inference that it is not been evaluated in any different methods. So
different methods means I'm not understanding the question.
the inference value that you have added, not in the study
Inference.
that you have done.
The inference time is calculated using our own system, ma'am. With the i7 CPU and that 3050 Ti GPU.
Okay.
Okay, ma'am.
Thank you.
Okay, thank you. Should I stop sharing?
Yes, you may. All right, we'll now move to the last presentation for today. Next, we have Vaishnu Devi, who will be presenting lightweight CNN with explainable AI for ovarian cancer detection using ultrasound imaging. You may now begin your presentation.
Am I audible, ma'am?
Yes, you are.
Okay. Can you share my presentation? Hello.
It's loading. Just a moment. Yes, we can see it.
Good morning, everyone. I am Vaishnu Devi from Sambalpur University of Information Technology, presenting my research topic on lightweight CNN with explainable AI for ovarian cancer detection using ultrasound imaging. Here are the content of today's topic, and my focus is to develop a lightweight, accurate, and interpretable AI model for assisting ovarian disease diagnosis. Coming to the introduction part, ovarian cancer is one of the most deadliest gynecological cancer because it appears on the advanced stages only. Because like early detection of the ovarian cancer, it is very much difficult. If we'll be detecting in the early stage, then it will be giving an survival rate of more than 90%. The symptoms like nausea, bloating, pelvic pain, we are often ignored. Like people ignore that type of symptoms. So if we'll be capturing that symptoms, then we'll be getting the survival rate and we can detect that there is an ovarian cancer or not. Then the survival rate will be more than 90%. So coming to why I have selected ultrasound imaging, because it is cost effective and it is non-invasive. Ultrasound imaging interprets depend heavily on the radiologist experience. If there is a good radiologist, then they can give the accurate whether there is a cancer or not, they can give that. So therefore I have automated an AI based diagnosis that can improve the accuracy and also helps to reduce the human error. Coming to the next slide, that is the literature review. So, we have reviewed this several studies, and in which we are seeing that the existing models like DenseNet, NASNet Mobile, and ResNet, they are giving a higher accuracy, but many models are computationally heavy. So some lack explainability, others are unsuitable for deployment on portable like medical devices. So our proposed model, MobileNet V2 plus SVM classifier, and also we have added GradeCam as an explainability. It gives an higher accuracy while keeping the computational cost low. Coming to the next slide, what is my motivation? The three important challenges here we were facing, that the first one is edge computing. Like in the hospital in rural areas, they are often lacking the powerful GPU. So we want to develop a low parameter count model so that they can be portably used in like mobile phones. We can, like in the rural areas, like they are not having powerful GPU, so we can use in the help of phones. So that that's why like AI model is required. So the next one is clinical trust. Doctor needs to understand why the AI has made the prediction. Like our work in the explainable AI is like it has to give the perfect area. It will be indicating that area where the ovarian cancer is detected, and then we can the clinicians can easily identify whether it is true or not. So the third one is like it is an hybrid approach. Here CNN extracts the powerful image features, where SVM performs the robust classification, and combining both gives an overall performance. About the data set, we have in the data set we are having 6879 high resolution ultrasound images, which is divided into 5 classes, that is healthy ovary, dominant follicle, polycystic ovary, simple cyst, and complex cyst. This data set is we have balanced in the training period time. Coming to the proposed model, so there are 4 stages of the proposed model. First, the pre-processing part, we have normalized the resizing into 224 into 224 into 3 pixel, and the mapping of the channels is in the range of 0 to 1. Here we have removed the corporated and unreadable images, and then the data is split into 70 into 30. That is 70% for training and 30% for testing part, and stratified sample ensuring the equal classes distribution, which helps to improve the model reliability. Coming to the next, like how it is like 1.8 million parameters, the model of my MobileNet V2. So here we have used the depth-wise separable convolution, which is using the inverted residual block, and we are using the width multiplier as 0.75, which is helping to reduce the channel in each layer, like to maintain the richness and as well as reducing the parameters. So that's why we have done 0.75 as a width multiplier, and the total trainable parameters are only 1.8 millions. So we can see in this particular image. So here we have taken the first, we have done 1 cross 1 expansion, that is h into w into c, it is there, it is added in the convolution into the number of channels, that is t into d, which allows the network to learn the richness feature representation. And then it is next it is done 3 cross 3 depth wise convolution that extract the spatial features for like computational cost compared with the standard convolution. And then again, that is 1 cross 1 projection convolution, it is compressed that the expand like channel, the C channel is creating the compact output presentation. So this method is called narrow wide narrow channel pattern. So here it is used to get the fewer parameters, high accuracy, and less computation. So coming here the advantages is like it is giving the faster training, low memory consumption, as well as like suitable for mobile and edge devices. Coming to the next slide, that is feature scaling and classification. Like after feature extraction method, the features are standardized using Z-score normalization. Here the standardization is given in as mean is 0 and standard deviation as 1. This is to represent the feature from dominating others, and this is the formula here. And then we have used the support vector machine with RVF kernel. Like RVF map is used for higher dimensional space, that is 1280. Here we have used. This improves the separation between different ovarian classes. And then lastly, we have used the grade cam analysis. Here, like GradeCam produce the heat maps. Heat maps is used to highlight the reason like responsible for the particular prediction. So here that like after like using the heat maps, doctor can verify whether that model is focusing clinically meaningful, like giving the accurate like image or not, like detecting the accurate place of ovarian cancer or not. For example, we can use like for separating for the separation in the complex cyst, for ovarian stromas in healthy ovary. So this GradeCam improves the trust in AI prediction. So, like coming to the overall accuracy, we got 98%, and F1 score we achieved, that is 0.97. This indicates that we are getting the higher precision, higher recall, and having a balanced classification across all 5 classes. Coming to the confusion metrics and the learning curves. So here, like most images are classified correctly, but there is a small confusion in between 2 classes, that is simple cyst and complex cyst, because like both of them are having a similar ultrasound appearance. That's why it is like not giving like a 1.0 F1 score, but we have taken the average, that is 0.97.
Excuse me, I'm sorry to interrupt. You have 1 minute left.
Okay, ma'am. Okay. Yeah, coming to the learning curve, here the training like accuracy is like increasing steadily, and the variation accuracy is like stabilized between 98%, and there is no significance of overfitting. Coming to the last, my conclusion is we have demonstrated that an ultra lightweight 1.8 million parameters model can deliver allied diagnostic accuracy while remaining completely transparent and deployable on resource constraint hardware as well as in the clinical edge. So coming to the future work, we want to like have a real time deployment in the hospital as well as inclusion of biomakers, also add large multi-center data set to develop a mobile healthcare application. Thank you.
Uh, have you worked on any of the real data set, ma'am? Have you received any real data set for the same?
No, ma'am. Like we have like recently, like I have worked on the like available data set, and we are approaching different like hospitals for the real time data set.
Because in that, according to your presentation, you are analyzing a different what a radiologist data set, right? So radiologists, whatever may be the data set they will going to be given. In that, can you please tell me what is the difference between the layer cam? Because you are working on the grad cam, so what is the layers cam in it? Layer cam?
Layer cam.
Yes. Because there are 3 different techniques. One it is layer cam, score cam, and the eigen cam. So have you analyzed something on this? Eigen and the grad you can combine two so that you're going to give the better results in the same.
Okay, yeah. In the like as I know that in the layer cam it goes to the deepest layer, right, ma'am?
Yes.
Okay, like
So have you analyzed something on it?
no, ma'am. Like further research, I'll be doing that.
So the layer cam it is going to be help you in it. So it is going to give you the comparative analysis of both these particular study. So again, it will going to help you.
Okay, ma'am. Okay.
Can you please go to the slide number 4? Go to above. Have you done the implementation of the system?
Yes, ma'am. Yes, ma'am.
Yes. Yes. So the how many process system architecture according to that, how many phases you have been completed?
Like it is in 4 phases. First pre-processing, then feature extraction, classification, and explainability.
How many you have completed?
Ma'am, it is all done.
You are
Like,
everything it is done.
yes.
So rather than the grad cam, if you can work with the layer cam, you're going to give the better result.
because it will going to be integrated for the good transparency. It will going to be checked. And in that, why you have only focused on the support vector machine, because if you go through the machine learning, most of the result techniques are available, which are going to give you the better result. So why you are emphasizing only on SVM?
Like at that time, like when I was doing the research, like I was not getting that perfect accuracy. So
So
here in
through SVM, you are getting the
what, ma'am?
okay. Why you have only focused on the support vector machine, because later on most of the techniques is going to be available, which will going to give you the better result as compared to this. So it is any specific reason to use the same?
No, ma'am. There is no specific reason. I have tested like few models, but like SBM was giving the better result. That's why I have.
Thank you.
Thank you, ma'am.
All right. So that was the last presentation today. And with this, we'll move towards the closing remarks. I sincerely thank all of our authors for their excellent presentations and contributions in this session, and all our participants for being a part of this international conference. I hope the session was informative for everyone, and on behalf of the entire team, I thank you for your support during this 11th version and all the previous 10 versions of the conference. We will be happy to have you in the 12th version in 2027. All the presenters will be getting their digital certificates through email within the next 2 days. The publication will be live in 7 to 8 months. Kindly cooperate with the team of ICT4SD 2026. I would also like to thank our session chair, Dr. Rupali Vairagde, for chairing the session. And on behalf of the entire team, I would, sorry, one second. Yeah, on behalf of the entire team, I would like to present a token of our appreciation to the chair. On behalf of Team ICT4SD 2026 and Global Knowledge Research Foundation and partners, thank you so much for your valuable presence. I kindly request everyone to switch on their cameras for a quick snapshot of the conference.
Thank you. Thank you.
All right, thank you so much, everyone. Stay safe and take care. The session is now adjourned.
Thank you.